Good morning, good afternoon, good evening, good night, wherever you are, Fastmarkets Conference attendees. My name is Alex Grant, and I am moderating this very interesting DLE technology panel with some very impressive and knowledgeable folks. David started his career in lithium at Tesla, buying lithium chemicals and other battery chemicals, was a CTO of Lithium Americas, and for the last 2 years has been independent, consulting across the lithium and battery chemical space. Mark Machado is a process engineer at Hatch Engineering based in Toronto, who has worked on a number of DLE projects around the world. And Dana Graves is director of technology at Livent, which is the only company operating a DLE process in the Western Hemisphere, and has been operating for 20 years. And is also the picture of their operation, which I chose for this slide. So before we start, I just want to give a really quick overview of what DLE is. If you were to consult the internet on direct lithium extraction or rapid extraction or direct extraction or whatever you want to call it, you will find a lot of very confusing information. So I just want to make sure this conversation is framed well. A DLE technology is a technology which removes lithium or lithium chloride selectively from a brine. That's what it is. And it creates a lithium concentrate, which can be processed into a battery chemical. It does not immediately create a battery chemical in 45 seconds. And just because it is combined with ponds doesn't make it not a DLE technology. That is the definition of a DLE technology. There are 3 main families of DLE technologies, and they're all quite different. And there can be vast differences between members of each of these families. There's adsorption, which is a process in which lithium chloride molecule is selectively removed from a brine using a solid material. Ion exchange, where a lithium atom is removed selectively from a brine using a selective material. Or solvent extraction, in which either one of those mechanisms can take place with a liquid medium to extract lithium from a brine. DLE is not new. This is another photo of the Umbro Muerto facility where a DLE technology is used to take lithium chloride out of a brine concentrate. And to the right are some photos of DLE projects being built and operating in China, in Qinghai. These are just some examples of some of the developments that are happening around the world right now. I titled this panel, Does DLE Matter? Because a lot of people don't think it matters at all. A lot of people don't think that significant number of lithium atoms will be coming from natural resources and reaching batteries via a DLE technology in 2030. I personally think those people are wrong. In this panel, I really just want to get, kind of to the heart of the matter and figure out, where does the hype come from? What is real? What is relevant? What is actually going to get built? What are some of the things that investors and project developers might want to kind of understand to be able to parse that information and make the right decisions? And just a note, there's lots of information about DLE on my website that you're welcome to go explore later on. So welcome, David, Mark, and Dana.
Thanks, Alex.
Thanks, Alex.
Thank you.
First thing first, because this panel is titled as a question, I will ask each of you directly. Does DLE matter? If it matters, why does it matter? What are the constraints of its mattering? Dana.
There's a lot of lithium available in the world today, and some of it has to be developed. Direct lithium extraction is a tool in the toolbox to be able to do that. Mm-hmm. So I think direct lithium extraction definitely matters. It's going to help add to the tools in the toolbox to be able to exploit lithium resources that we haven't been able to up until now. Our particular extraction technique works very well in our brine source. Part of the issue with DLE is matching it to the resource. Mm-hmm. But that's to me, yes, it definitely matters. It's a tool in the developer's toolbox to be able to get lithium to market.
Mm-hmm. So Dana, what you're saying is potentially like I wouldn't be able to just copy and paste Umbro Muerto's process on the Atacama or any other resource?
Our technology works in a lot of different brines. I tell my guys all the time, the chemistry and the physics have to work first, but then there's another little science that we have to work on called economics, and the economics are sometimes where the break point is. So I can take really, really weak lithium brine, and I can process it through our technology. It just takes me a very long time to do it.
Right.
And it's not very economically feasible. I can also, I also sort of have an upper limit where if it's too much lithium, then I've got another thermodynamic issue on the other end.
Yeah.
So it's got a window that it works in. That's our technology. Now there's other technologies that have different windows. You have to match that technology to the resource to get the end product.
Agreed. Mark, what do you think? Does DLE matter?
It really does matter, and we need it. Obviously, as lithium demand grows, it will become a bigger part of the overall supply mix, I'd say. I think there's several drivers for that. There's a greater focal point on, looking at the carbon intensity of processes. Consumers are really driving this change. They're putting a spotlight on the overall supply chain and how lithium is ultimately sourced. So I think DLE can play a role in this transition to produce potentially a more environmentally sustainable product. In addition to that, I think DLE matters because it can unlock some of these non-conventional brine resources that were maybe not in play before. So we can access, for example, or extract lithium from tails brines from existing operations, where the infrastructure is maybe in place and you're getting more out of the same resource. I also see it in being useful for extracting lithium from geothermal brines. You get the benefit of generating clean geothermal power, but in combination with that, you extract the lithium. And DLE is intrinsically tied to being able to do that. Lastly, I guess it's important for the regional integration for battery manufacturing. It enables countries to become more resource independent and supply their own lithium and other, secure their critical mineral supply, and overall integrate supply chains for electric vehicles and electric storage as part of that economy. So I think it's important for all those reasons.
David, does DLE matter?
It certainly does. And just echoing the comments of Dana and Mark, what I'd argue or sort of say is that DLE technology can enable new resources to come online, ones that in the past may have been challenging. DLE also provides a platform effectively to extract lithium in a more sustainable way. I mean, I think what DLE in particular, there'll be certain direct extraction technologies that will help to improve the operational footprint of different resources, so that you'll be using less significantly less water footprint than what's experienced today. You'll reduce like the land footprint as well, and in particular as well, you have the potential to reduce the operational risk. When you use evaporation ponds today, there is a lot of seasonal risk with how your productivity of your operation is going, and it's really important. DLE technology will absolutely sort of address that. A couple of hurdles to deployment really comes down to proving first and foremost that a technology or new technologies that are coming to market. But with every DLE platform, you have to also think about how you're going to operate brine resources differently than in the past. Because in the past, there's been such a focus on extraction of the brines, but not necessarily the re-injection of the spent brine, of the lithium depleted brine. So there has to be a solution when you're developing resources about how to work with that. There are solutions that can translate from the oil and gas industry in particular. And as lithium demand grows and the resources become developed, DLE technology will play a key role in enabling new types of resources that were previously considered uneconomic to be attractive.
So good. So the common thread between all of your answers to that question, DLE unlocks new resources that previously were not economic. It lowers the cutoff grade for brines to be economic, and it unlocks new brines which previously were not economic. Is that important because, would you agree that that's important because the best resources of different types of resources have kind of already been taken? Like the Atacama is already spoken for, Greenbushes is already spoken for. So we're going to have to move on to the second best and the third best and the fourth best.
I would actually argue that lithium extraction technologies applied to current resources that are in operation could be enhanced and expanded with a new type of approach and platform. You could increase productivity, recovery rates, decrease water footprint. It could be an outright substitution for evaporation pond processes, or a complement to existing operations that can enhance productivity and outcome.
It is the tool in the toolbox, and that's the way we kind of look at the technologies. Like David said, can be applied to existing operations and can actually help your economics and your yields and your sustainability metrics and everything. So
something I found really interesting when I became independent, like just under 2 years ago, was to realize, like, doing research into all these different DLE technologies, like right now I'm tracking, I think, like 60 different ones, was to realize that they're all proposing the exact same advantages. We're going to make lithium chemicals in 2 hours instead of 2 years. We're going to reduce water consumption. So yeah, like DLE is certainly not one thing, right? Like there's so many different ways to do it. Like Mark, like when you're working on new DLE projects at Hatch, when like, you know, for example, junior developers approach you, you know, one thing I know that you do is kind of technology reviews, right? Are all DLE technologies created equal?
No, I wouldn't say that. I think, as you mentioned, there's probably, there's over 60 now out there. A lot of them are very similar. They don't differentiate very well against each other. But there's, 3 or 4 main classes of technologies, and within those boxes, there's, one or two front runners that have done more refinement development in their technology. And it's really, those ones that are, further along and have gained traction that are going to be able to market themselves well, court investment, manage the risks, and ultimately successfully commercialize the technology. The key for them, though, will be to structure their offering so that they can, allow for the technology to be applied, widely, I guess, across various brine resources. Once, a few of these technologies become the incumbent technology in place, then I think a lot of these other technologies will simply find it difficult to, find financial support.
What are some of the mistakes that DLE technology companies or project developers are making? Yeah, like David, you're familiar with some really interesting phenomena of the last decade. Like, what are some of like the main mistakes that technology companies or project developers are making, and like what are some of those like key takeaways from your experience that you kind of wish more people like understood?
Well, I think to start out with, when it comes to assessing different extraction technologies, you need to set sort of criteria or benchmark for selecting and analyzing and understanding upfront which might make a good technology. And there's a lot of technologies out there that actually don't meet some very basic criteria. A good DLE technology is one in which concentrate the lithium and you purify it. There are some technologies out there that do a really good job at purifying, so getting rid of impurities, but don't concentrate up the lithium. So that means such technology, such approaches will require an extra step or an extra amount of energy effectively to concentrate up the lithium in solution. And another thing I would say as well is that you got to reduce what might be the water footprint compared to what the incumbent or alternative approaches are. So if you're going to be using an approach that requires more water consumption, especially more fresh water consumption, that's not that's not the direction you want to be going in. You want a technology that's very robust, that will have, last thousands of cycles as opposed to, hundreds of loading and unloading cycles. I'm a fan of approaches that also use small amounts, if no reagents at all, if possible.
David, are membranes a DLE technology?
Membranes are a technology that you have to couple with something else in order to meet those criteria of purification and concentration. Because membranes do a good job at purification, but you need extra functionality or a combination of another technology to help concentrate up the brine.
And just for clarification, like there are many kinds of membranes used in processing, right? Like there's nanofiltration membranes, which maybe have some utility in, monovalent, divalent separations. There's electrochemical membranes, which are totally different, et cetera. But we're talking about kind of nanofiltration-esque membranes.
Yeah.
Dana, so, I'm tracking 60 technologies. Like, I've heard that some major lithium producers are tracking like hundreds, right? Because these little technology startups in the Northern Hemisphere, like, I want to understand, like, what are like the worst technologies people have come to you with?
I think I'll play off a little bit of what David was saying just a second ago, is that we will look at different technologies, and we do get a lot of cold calls if I've got the greatest new thing, and
Yeah.
we'd love to have some of your brine to try it, and we'd love to do this. The ones we reject right off the bat are the ones that, if it's requiring some kind of really ugly solvent or some strange chemical, and we're not going to be able to put the brine back just like we found it,
Yeah.
we're not interested in it. So, there's ways to get lithium out of something with a price, or there's ways to get lithium out of something where you can still maintain the environment that you're in.
Yeah.
And
noted. Yeah.
That is to us, that's a very important thing, is that we do want the vicuñas and the flamingos and all of them to have their place on the earth as well. So
I feel like this is actually a mistake that continues to be made over and over and over. I think of like the Northern Hemisphere scientist type profile, of which I used to very much be a part of, like that class of people. And like they're working on some kind of really interesting like organic molecule or something, and they think like, oh, this could be used for monovalent ion exchange, so like I'm going to make a DLE technology to save the flamingos. Like what you're saying is like, if it's some kind of extremely fancy molecule, it's like probably going to be high cost. It's probably going to like have like compatibility issues with the resource. Like, is hydrochloric acid and lime or sodium hydroxide, are those fancy chemicals, or are those acceptable for use on solar?
We pull chlorides and sulfates, and there's 75% of the periodic table is in our solar. So if you're putting chloride back where you took chloride out, it's probably, you've changed a few atoms around here and there, but you're not changing the chemical structure of what you're putting back in. Yeah. So I would say HCl is, look at all the chloride that's up there. Right. HCl is not something that we would consider to be outlandish. Right. Even that, we don't use a lot of it.
There's a lot of brine across the Western Hemisphere in both North and South America. But if you had to put together a list in your head of projects you think will be producing more than 10,000 tons per year of LCE in 2030, how many projects do you think are going to be on that list?
I'm going to be optimistic and say it's going to be in the 5 to 10 range. There are reasonable brine sources that haven't been fully developed, and that I know are in development. That I would say there's a possibility for as many as that.
Mark?
I'd say at least 5, probably more, but I think conservatively I'd say probably at least 5 that have a good shot.
David?
I would agree. It's somewhere between 5 and 10. What makes a resource attractive for development is that you need a combination of the right grade of resource, but more critically, I would say, is scale. You want to be able to, if you're going to deploy a 10,000 or 20,000 ton LCE plant, you want to make sure that what you deploy there is expandable, that it can go from 20 to maybe 100. And so that's what's really critical for me when I think about what makes a good resource and a good platform, is you have to have access to scale.
Yeah, so my number is 6. I actually have a number in mind, which is exactly in the range that we just discussed. Sorry, just to reflect on something you just said, David, that I think is super true. If you're going to compromise on grade, right? Like if you're going to process a 250 ppm brine instead of a 1,000 ppm brine in Chile or something, like if you're going to push that lever down, then another lever has to come up, right? And that lever could be resource size or like dream team or something else.
Yeah, and also a comment on the grade. with the right technology approach, with brines in particular, there could actually be benefits of having a slightly lower grade brine than some of the richest, highest grade brines in the world. Like there are certain advantages and tricks of the technology that can be leveraged. For example, if you use a slightly lower grade brine, there might be ways that you can maneuver the process in a way that you use less water than you would otherwise use if you're using a higher grade brine. So there's the difference in cost between what might be a super high grade brine versus a medium grade brine. That differential might be negligible with the deployment of the right kind of technology platform. Exactly.
Sorry, Mark, were you going to say something, Mark?
Yeah. I guess maybe equally important. I think the brine grade is a critical consideration, but the impurity profile of that brine, what else is there, is also paramount in the decision-making process, because obviously it could impact the front end of the flow sheet, and it may require and necessitate major pre-treatment steps, for example, to remove certain impurities to enable the DLE technology to work as effectively as we'd want it to work. And so I think that's another key consideration.
Dana is operating kind of DLE on easy mode in Argentina. And I mean, he just told us that he does some pre-treatment to some extent. I mean, you don't need to we can talk about potash if you like, Dana, but it sounds like the brine chemistry is changing a little bit before it hits that column. Maybe brine chemistry modification is actually it's not like an exception to the DLE rule. Maybe it's.
I think obviously you'd like to stay away from brine pre-treatment if you can, because that's where you've got the most water there, so the most volume. So if you can do your extraction without having to do a lot of adjustment, that's the best of all situations. You want to try to minimize your pre-treatment if at all possible, because that's, again, the economics.
Let's reflect on that poll for a second. The four of us come at DLE from radically different places. And we agree that there is a very high chance that between 5 and 10 DLE projects will succeed in the 2020s and get built and make hundreds of millions of dollars selling lithium chemicals. That's really interesting, right? And that's just the Western Hemisphere, right? We're not talking about Europe. We're not talking about Upper Rhine Valley. We're not talking about China. We're just talking about the Western Hemisphere. Why do I have to title seminars, Does DLE Matter? If from our perspectives of kind of insiders, working on real projects and understanding how DLE technologies work, why is it not obvious to some people that DLE is real and it's going to have this impact in the 2020s?
I think you have to think about the lithium space more broadly when answering that question. Lithium is a small market and it's growing, but in effect, it's embryonic compared to the scale at which it's got to grow to. And there's not been, massive amounts of investments in, extraction technologies and approaches generation compared to the kind of investments that go into batteries or semiconductors or whatever. There's that context that we're at the beginning of what will be a very innovative period over the next 10 years, where there will be more investment, there will be growth, et cetera. With that said, though, you look back at, the last decade or 15 years of project development, some of which have used and tried to use DLE technology and deployment. The lithium space is littered with a graveyard of unsuccessful deployments. When it comes to investing as well, there's a lot of risk. I mean, if you look at the track record of the industry as a whole, it's littered with either projects that never came to market or major delays or budget overruns. And so adding on the sort of at least perceived risk of new technology compounds that risk perception.
Don't you think the perceived risk of evaporation ponds is actually kind of erroneously low? A certain project, which was built in the 2010s, deployed conventional technology, and it didn't work very well. right?
Yeah. I mean,
And what is conventional about like copy and pasting Atacama processing to Argentine lower grade, higher impurity brines?
Well, it's conventional in the sense that, you know, the very first projects that were deployed in lithium extraction from brines were evaporation pond processes. But you're right. Like there's this perceived low risk of evaporation ponds, but actually I would argue that, yeah, operationally and deployment wise, the risks are quite high with evaporation ponds, which is why I'm quite partial to direct lithium extraction platforms. Is that I feel like the future has to go in that direction where you really reduce operational risk. And
so something must have kind of changed in your head in the last couple of years, right? Like you were associated with the junior project, which kind of went down a pure evaporative route. And you know, we can talk about potash if you like, but like, you know, like why is that not a DLE project?
Well, so I've actually, you know, ever since I have entered the lithium space, when I was at Tesla, I was always a fan of direct lithium extraction. When working with Lithium Americas, my former employer, there was, you know, we partnered with some of the largest players in the industry. We were looking at commercially expedient pathways to production. I mean, you know, when you're doing project development, there's a real focus on getting to market as quickly as possible to create cash flow and, you know, create your returns on investment. The luxury of time was not on our side, so to speak, with regards to building out what might have been like a 5+ year development roadmap for finding or developing the right kind of lithium extraction technology. You know, I'm aware of platforms that I think can be deployed relatively quickly. And in particular, there's one that I'm a big fan of, but I was not aware of that, and nor was the development of that platform ready until the time I had sort of left my former employer and started working more independently. So
right. Dana, why are my LinkedIn posts a lightning rod for these cranky guys who don't like DLE and think that lithium will always be a byproduct of something else from brines? What do they not know? What do you know that they don't know? And like, why are there going to be 5 to 10 projects in the Western Hemisphere by 2030? What is this information you possess?
Lithium is a byproduct of other processes, because the other processes are, if you can get more from an extraction than just lithium, and you can run multiple operations at the same time, why wouldn't you? And if you can get a lithium stream that somebody else pre-processed for you to get something else out of it, and then you can do lithium with it, you know, that's a wonderful thing too. Again, I think it comes down to source and desire for what you want to do. You know, the same thing happens in hard rock. There's a lot of hard rock where lithium is part of something else that comes out of it. So, you know, you got boron and lithium. You've got all kinds of other things that you get at the same time. So it really comes down to what you want. And if you're going to be just lithium, DLE becomes a legit way to go do that.
Yeah, so DLE makes sense when, you know, the market for lithium is growing 15 to 20% a year and everything else is growing at GDP potentially.
I think I said this to you before, but you know, lithium is a growing market at this point, and I think there's a lot of different options to get that first lithium into play. Lithium technology is going to mature someday, and there will be a lithium technology that everybody will apply. If you're in hard rock, you'll do this. If you're in brine, you'll do this. And when it matures, the lowest sustainability impact will be the one that wins. So the ones that advance the electric vehicle value proposition, that we're going to make the world better with electric vehicles, will be the ones that ultimately 30 years down the road, 40 years down the road, are the technologies that will be cut and paste and stamped into lithium all the way. That very well might be lithium battery recycle at that point.
Right. Mark, what do these retired guys on LinkedIn not know that you know? that makes you think that 5 to 10 operations will exist in 2030 and makes them think that there won't be?
Yeah, I think, as you mentioned, it's a very polarizing topic. DLE will be, I think it's going to play a role in the future of some of these pond resources. I think it's, I don't like to look at things as kind of binary. I think you're going to see hybrids of things. You may have, a hybrid pond system and then using DLE on the back end, maybe maintaining existing production of byproducts, but while extracting maybe lithium at a higher recovery. So I think it's going to be a lot of these, it's a toolbox, and a lot of these processes are going to morph, and it's the most sustainable and economic of these processes that will remain. So,
do you all believe that there will be a portfolio of technologies deployed in 2030, or do you think it's going to be like one that succeeds and then everyone else adopts?
Room for probably one, maybe two different types of platforms, because you will gravitate towards the one that will provide what will be the most economic, lowest footprint possibility available.
Mark, what do you think?
I agree. I think there's just a handful. And once those technologies get a foothold and they become the incumbent technology, then I think some of these alternative technologies will just fall by the wayside, as they won't be able to get the financial backing they need. The mining industry is very risk averse, and they're going to go with what works. And once something works, then it's very hard to deviate from that.
Dana, what do you think? How many technologies will be used in 2030?
We can't continue to have a smorgasbord to choose from. There's just too much technical risk involved in it. If you're going to develop something, as David said earlier, you've got to reduce the technical risk, and that's sometimes the barrier to some of these things actually coming in. Is if it's going to take me an extra 2 years to put my project in because of the technology that I'm trying to deploy, then people are going to go back to something that's more secure.
I think I agree with all of you. I mean, I don't think that if there's 7 projects, I don't think there'll be 7 radically distinct DLE technologies, but maybe 2 or 3, something like that.
And I would also add the comment that, you had asked me the question about membrane technology. And so the place for membrane technology may be not necessarily in the purification and concentration of lithium per se, but more in the application of how you might take that stream of purified concentrated lithium chloride and pass that through a electrochemical process to make the kind of products that you want, for example.
Let's not forget reverse osmosis. I mean, I don't think I've seen a DLE flow sheet that doesn't have RO in it for water recovery.
Right.
That's a membrane process. That's critical, right?
Exactly. True.
Mark, for all the Northern Hemisphere scientists and engineers in their garages developing DLE technologies, as the person who's thinking more broadly about how the thing is going to get built, what do you wish they knew?
Yeah, I think the first thing is there's a minimal requirement. This is DLE. It has to be selective. So if it's not selective, then there's no point. So, and it has to be selective for some of the key impurities. It has to, for example, be able to remove divalents very well, because they're in every brine. So if it can't do that, then it's not worth it. The other thing, I guess, is the technology has to, looking back in the context of the flow sheet, to Dana's point, the big flows are on the front end before DLE. So if you can minimize, if your technology is flexible in terms of the feedstocks and can handle a wide range of impurities, then it would minimize, the capital cost expenditure on the front end of the flow sheet, whereas you have where the most impact is. Those are the 2 key things. The third thing maybe is minimization of OpEx, and that's through processes that don't consume a lot of reagent.
I want to compare unconventional brine DLE to hard rock. If I'm an investor and I've got a spodumene project on my desk, first of all, and then on the other side of my desk, I have an oil field or a geothermal brine with a novel DLE process. And I could put X $100 million into either of them. What are the parameters that investor should be thinking about when evaluating the DLE project?
Any resource development is at risk. There's as many hard rock projects that have had difficulties as there are new developments. Every natural resource has its own has its own footprint and its own profile and its own challenges to go through. Taking out jurisdiction and things like that, I don't know. That would be a hard one to say, because you never get that opportunity to take out jurisdiction and
Right.
and governments and local resources and those kinds of things. So difficult to say.
Mark, what are the green and red flags on evaluating a DLE project?
How advanced it is, I guess, in terms of its technology development. So, are we talking about something that's still at lab scale, or, has it been piloted? Has it been ultimately demonstrated? Is it commercialized? Those are the major limitations, I think, from its widespread adoption right now. And I think that's, it goes back to risk, and, mining investment goes to where the least risk is. And that's why, they tend to favor the conventional processing routes right now, but that may change over time.
Dr. Deak, what are the green and red flags on evaluating a DLE project?
Path to commercialization. Like when I assess technologies and options with regards to what might be the best fit for a particular resource, I want to be sure that almost everything, if not everything, that ends up being part of that flow sheet has been used commercially before, or otherwise is an innovation upon something that's been commercially deployed before. That's what I would say is like the key thing that I look for. A red flag would just be, does the technology require a lot of reagents and water, for example? And if it does, that's a cost adder to any flow sheet. And like the comment I made before is like things like the durability and reliability of the platform. Where's the data that shows that this can run for months without any degradation in performance? I mean, this is pretty standard fare with regards to evaluation, et cetera, but that's what I would say. And with regards to whether to invest in hard rocks versus brine, it's they're both great opportunities, because the market's going to have to grow so quickly anyway that that both are going to be required. There is trade-offs between one and the other. If you're going into the brine space, you have a different technology and risk profile compared to if you're deploying hard rock resources. But on the other hand, you definitely have a higher CO2 footprint when you're mining lithium out of hard rocks versus brines. So there's a trade-off one way or another, which route you choose. And I would say it just depends on the investor. If the investor comes from like, let's just say they come from an oil and gas background where they're used to dealing with fluid resources, like quite literally fluid sort of brines or oils, et cetera, they may be more comfortable investing in brines versus a traditional mining investor might want to lean towards hard rocks because that's what they know.
I'm glad you bring up the environmental impact side, which I'm very vocal about, and I'm interested in DLE. I mean, really principally because delta G equals minus T delta S, right? Like in a DLE process, I don't have to input a huge delta H into my system. Sorry for my folk thermodynamics. I don't know. Hopefully, no physicists are watching. But like fundamentally, a DLE technology enables upgrading and purification of a lithium stream without having to roast a rock at 1,000 degrees Celsius. How do you think DLE technology companies and projects should communicate their environmental performance? Dana, how do you understand that? And like, are any of those advantages realized at Umbro Muerto today?
Sustainability is really important to us. We take the value proposition of the electric vehicle very, very seriously. So we are constantly looking at, we're in a low water area. How can we reduce our water footprint? It's an important piece. And I think part of what we have to do as an industry is we have to sort of normalize on what those are, because like you said, I think there's a lot of different stories out there. At the same time that we worry about sustainability, we don't want to weaponize it against the lithium industry. So as a lithium industry, I think we need to do better at having an open dialogue about how to measure sustainability and what it means, and to do that with our customers, because ultimately this is all part of the footprint of an electric vehicle.
David, do you think that LCA is kind of contributing that framework that Dana is kind of like looking for understanding how to talk about environmental performance and impacts?
Absolutely. I mean, life cycle assessments are the tool for analytically and quantifiably understanding your environmental footprint. And it categorizes it in whatever in whatever areas you want, whatever factors you're looking for, whether it be CO2 intensity, water intensity, land footprint, and it can also help you articulate and delineate, where your impacts lie. And it provides that kind of toolbox that will allow you to make decisions, whether you're an investor trying to understand what the impacts are of a particular deployment and how a certain DLE technology might impact that footprint on the one hand, but it's just as helpful, if not more helpful, for the engineers to understand, well, okay, here's a really clear picture of our environmental impact, and it can help engineer ways to reduce that footprint and correspondingly reduce your cost footprint as well. Like I'm a huge believer in reducing footprint no matter what, like whether it's your land footprint, water footprint, reagent footprint, CO2 footprint. These all are drivers that reduce cost ultimately. It may require some ingenuity, but again, the clarity that an LCA can provide can help with innovating towards a cheaper flow sheet.
Mark, do you agree with David that there's a monotonic and positive correlation between OpEx and environmental impacts? So, for example, spodumene has relatively higher OpEx to make lithium chemicals from compared to brines. And also higher CO2 intensity. Is that an exception to the rule? Is that the rule? Does that make sense to you? Like, and how do you as an engineer and kind of integrator use that idea to kind of kill two birds with one stone for your clients?
Yeah, absolutely. I think there's definitely a correlation. If you, for example, minimize reagent consumption or you improve your energy optimization on the back end of a flow sheet, for example, you're in effect, you're reducing the carbon intensity of the process, and it's also helping the economics of the project. So they go kind of hand in hand. Mm-hmm. But I concur with what David and Dana had mentioned. We need some transparency and a standardization of metrics, so that we can effectively use this information to improve the overall process design and develop these projects properly.
Feedback, yeah.
Yep,
cool.
Exactly.
Yeah, that's what it's all about, in my opinion. Let's build the new energy system using the tools of the new energy system, because otherwise this whole thing's not worth it. We can all go home. Well, good. This conversation has been amazing. I hope that the people who listen to us talk got something out of it. There's many different stakeholders at this conference. There's buyers, there's investors, there's project developers, there's operators, and they all have different viewpoints, and they're all looking for like different kind of types of information on DLE in particular. And I hope that I hope that the kind of viewers have gotten something out of this that is helpful and interesting. So I guess before we sign off, any kind of final thoughts? Any kind of conclusions or kind of recommendations to the industry with respect to DLE?
I just would like to say, DLE, like I said, DLE is one of the tools in the toolbox, and I think we need to continue to develop it and get to that point to where it's a deployable tool to get to some more economic lithium. And I support you that DLE does matter.
Mark, any parting words? No, I concur with what Dana just said. I think DLE does matter, and it's going to be part of the the supply chain mix for the years to come.
David?
Yeah, for me, I envision that the lithium market, a certain portion will come from hard rocks, a certain portion will come from sedimentary materials, and a certain portion will come from brines. And what I see for the future of brines is a future in which you deploy DLE technology with the right kind of re-injection platform as well, and brine re-injection back into the resource. That is what I see as the future of brine resources.
Thank you all so much for joining, and thank you all conference attendees for listening. And we look forward to connecting. You can find me pretty easily on the internet, and I think Mark, Dana, and David are also all very responsive.